What the heck is up, everyone? It's Jacob here, and today I want to do a quick little video just talking about quick charge. This is made by Qualcomm, so it's Qualcomm's quick charge technology. I'm just going to kind of run through all the quick charge 1.0, 2.0, 3.0, and now there's a 4.0, but I just kind of want to talk about what quick charge is and kind of how it works, just very generalistic. We're not going to get into the actual spec sheets and look at all the standards and how they're written for quick charge, but so for those of you guys who don't know what quick charge is a technology developed by Qualcomm. You usually see it on a lot of Android devices. We'll actually take a look at it on my LG V10 here. So it's not really an Apple thing. Apple doesn't really have it yet. They haven't developed their own thing, and again, it's proprietary. Quick charge technology was developed by Qualcomm, and basically its goal is to charge your phone in a shorter amount of time. Obviously, that's why it's called quick charge. So it does this various ways. We'll look at that, but essentially what its main goal is to deliver more power to your phone in a shorter period of time, and it does that several different ways through several iterations of the technology. First they had a quick charge 1.0, then a 2.0. My phone here uses a 2.0, and we'll look at that, and then they use a 3.0. And so there's good and bad to all of this. So one really obvious, just straight up blunt reason that this thing is bad, you can tell already, is because it charges your battery faster. Now that might be good, but it also severely reduces the life of your battery in your phone. And especially for my phone, I have a removable battery, so it's not that bad. I've actually noticed it a lot. I had to buy a new battery recently because the battery in my phone it was horrible. I cannot say I regret using the quick charge technology. It's great, especially when I want to charge up my phone really quick, but it does heat up your battery a lot, and because it charges your battery at higher C rates, your battery has a shorter lifespan. So if you were using something like a Samsung, S7 or whatever, it would be a little bit more of an issue, because when you want to replace your battery, it's not quite as simple as just pulling it out of your phone. Something like the LG V10 or another phone where it has a removable battery, it's not too big of a deal because I could just replace the battery, just costs 10 or 15 bucks or whatever it costs to replace the battery. So it's not that big of it's not a huge process. So that is one of the main fallbacks of quick charge. It's good, and that's gonna happen with any technology. It doesn't matter what kind of technology. That really relies on the battery technology. So it's good that it charges your actual device faster, but it does shorten the lifespan of your battery by, I would say, quite a significant amount in my case. So we'll look at some of the other detailed fallbacks of some of these quick charge technologies, but the main one I want to talk about real quick before we actually look at those is that quick charge is proprietary, and so what it does is it actually utilizes the D+ and D- pins on your USB port, because your USB port has 4 pins for USB 2.0 at least. So you have your 2 power pins and 2 data pins. And so what Quick Charge 2.0 does is it actually utilizes your 2 data pins to communicate between a charging brick and your phone or your whatever device you're connecting to, and it negotiates a charge level. And while this works, it's not anywhere defined in the USB standard, USB 2.0 or 3.0. It's a proprietary technology, and it worked fine for a while, but then later on they came out with a new USB-C standard. So the USB-C standard has no room, it doesn't have anywhere to find the quick charge technology. There's no standard for quick charge. USB has its own, what you would call voltage modes, I guess is what they would call it. So they're like voltage modes, and there's different modes at which USB-C will operate at, and it doesn't work anything like Qualcomm's quick charge technology. So what happened was you started getting these devices, these newer devices, with that they wanted to charge the devices faster, but they also wanted the new USB-C port. So there's devices that were pushing the new USB-C ports, and they were still utilizing quick charge technology. Examples are like the Note 7, and I've even heard people saying that the Note 7's battery problems weren't really due to the battery, but actually due to the incompliance of charging technologies, which I don't know if I quite believe that. It looks like it was the battery, but I don't want to get into that right now. But I'm just saying what I've heard, and it really is true that it is a major issue that a lot of people overlooked, and I think the engineers really overlooked that and saw it later on, because obviously Quick Charge 4.0 is coming out now. They're coming up with a new Quick Charge 4.0 technology, which actually is USB-C compliant. So really, the Qualcomm technology, what we started getting was bigger phones. They get they had bigger batteries, they started getting bigger batteries, so you needed to charge these phones faster. If you charge them with just 5 volts at 1 or 2 amps, it would just take all day to charge, and people didn't want that. So Qualcomm had their quick charge technology already out. They had quick charge 2.0 and 3.0, and then USB-C came around, and when they combined that proprietary charge technology into USB-C, we just started seeing problems all across the board. And those cables that would go from USB-A to USB-C, and you could try and just like, it was like an adapter or whatever, they were just cables that literally just took pins from USB-A and stuck them into pins of USB-C, and the USB-C standard did not allow for that, and it didn't have that anywhere to find in it. You couldn't modify voltage buses in the USB-C standards based on the data pins. USB-C has separate pins to modify or set voltage modes. You couldn't use data pins to do that. So it created a lot of compatibility issues. And I think that's the main reason Qualcomm kind of took a step back and developed their new Quick Charge 4.0 technology. I haven't really seen that on anything yet. I haven't actually seen any specs on it yet, but I know that they're developing a new Quick Charge 4.0 technology which complies with the USB-C standard, which is a major issue that Quick Charge has. So real quick here, I just wanted to show this to you guys. So here's Quick Charge 1.0. This is the first thing they came out with. It had a voltage of just 5 volts, so it was just a normal USB 5 volt voltage, and it had the ability to go up to 2 amps. Now this was a major step forward back in the day because a lot of phones, we were still using those smaller, 4-inch phone screens, stuff like the iPhone 4 and things like that were really small. So again, this doesn't really apply to iPhone, but we were using all around, the phones were smaller, so they didn't have as big of a battery, and they didn't need as much charging capacity. We didn't have to charge these devices as fast. The batteries weren't as large, and they didn't consume as much power. So 5 volts, 2 amps was kind of what we needed to charge these devices faster. Most devices could only charge at an amp or maybe an amp and a half. So this Quick Charge 1.0 giving us the ability to charge up to 2 amps was major. Now you can kind of see a flaw in this already. The problem is there's charging cables that don't really have the ability to carry 2 amps, or they might be too long and they might not be the right wire gauge, so you'll have a large voltage drop across that, which kind of it mitigates the ability to actually transfer this 2 amps of current, because you need larger than 5 volts, because by the time you go across the cable, especially if you're not using an OEM cable, you can have a voltage drop by as much as, say, a volt. And 4 volts is not going to be able to be used by the device. So the device is going to actually limit that current from 2 amps back to the normal 1 amp or whatever, because you're not using a thick enough wire gauge. So that was a problem with that. That's one of the main drawbacks of Quick Charge 1.0. So it's really hard to actually push 2 amps through a USB cable unless you're using a hefty USB cable and you have a little bit above 5 volts on your charging side, say 5.3, and that's why a lot of Samsung adapters actually go up to 5.3 volts. So then there's Quick Charge 2.0. This is what my phone uses. We'll take a look at this actually in action. Now this is good. This is a step up because it can utilize 3 different voltage ranges, 3 different voltage levels. It's not anywhere, it's not between these, it's any one of these 3 voltages. So your phone can use either a 5 volt charger, which is just normal charging. This makes it backwards compatible, so you can still use a USB 3.0, or I mean a Quick Charge 2.0 brick to charge an older 5 volt device. So it'll be backwards compatible. This could even charge to Quick Charge 1.0 or just any USB device. So that's what makes it backwards compatible. You can step up the voltage to 9 volts. Now this is really useful because it takes care of that issue that I was talking about before. You can actually use, and I've noticed this for sure before, you can use really small, thin wire gauges, and with that 9 volts, you can still push a reasonable amount of current. You can still push an amp and a half through that wire, even through a reasonably small, off-brand, chinky little cable. It doesn't matter. So that higher voltage level allows you to push more amps through that cable, or more current, and not suffer as many losses through your cable. Same thing with a 12 volts, just a little bit higher. So some devices can even utilize 12 volt, which allows you to push even more power through. The maximum current capability of Quick Charge 2.0 is 3 amps. And so I don't know of too many devices that actually charge at 3 amps. I've never seen any Quick Charge 2.0 devices that charge at 3 amps. A lot of them I see charge at like an amp and a half, or oddly enough, 1.67 seems to be a common number thrown around. Kind of weird that exact number is used, but 1.67 amps seems to be what a lot of devices I've seen actually use. So It'll basically use those data plus and minus pins to, it'll start out at a 5-volt charge, it'll charge normally, and then it'll try and negotiate a higher charge level and work its way up to 9 volts, and if the device is compatible, it'll work its way up to 12 volts. Not all Quick Charge 2.0 devices go up to this 12 volt level, only some of them do. And typically the currents are, like I said, under 2 amps, but it has the ability to go up to 3 amps, but I've never seen anything use that high a current. Now, it sounds all good on paper, and like I said, you know, you mitigate a lot of those losses in the cable using these higher voltages. But the problem with this now is that your phone does not operate on 9 volts or 12 volts. It doesn't even operate on 5 volts. Your phone operates on really low voltage levels, and your battery in your phone typically is anywhere from like 3.6 to 4.2 volts. So it's lower than 5 volts in all cases, which means that you have to actually use voltage regulators in your phone. You have to have either linear or switching regulators in your phone to take these voltages down and step them down to the voltages that your phone can actually charge with and use. And typically I think phones probably use like 3.3 volt voltage rails, so they're always taking this 5 volts and stepping it down, but your losses are small because, you know, if you're going from 5 volts down to, let's just say, 4.2 volts to charge your battery, that's not too much of a voltage drop. But it makes a large difference when you're charging anywhere from 9 volts or 12 volts, because you have to really step that voltage down. You need a larger power supply in the actual device, in the phone, and that creates a lot of heat in the phone. My phone gets very hot when it charges. My phone uses the Quick Charge 2.0 at 9 volts, and this 9 volts has to be converted down to a voltage which the phone can actually use, and that means it has to have a power supply, presumably a switching power supply, to be more efficient, but it still generates a lot of heat in the device. So that's a major problem with Quick Charge 2.0. It gets rid of that issue with current, with resistance losses, you know, in the actual cable from large currents, so you can push higher voltages through, which allows you to push more current through smaller wire. But the problem is then you have to do that voltage conversion, and you have to get all do that power conversion in the phone, which generates heat in the device, and it generates quite a bit, even for a 9 volt device. I would hate to see how hot it gets with a 12 volt. And if I'm doing any like major tasks on my phone while it's charging with Quick Charge 2.0, it overheats and shuts down. Which brings us to the latest and greatest, Quick Charge 3.0. Again, they are coming out with a Quick Charge 4.0, but we're not really going to discuss that yet in this video because it's not really, I don't think, official yet. I don't know, I haven't seen much on it. So this one is kind of, it's really nice because it kind of takes the best of both worlds and it tries to make it as efficient as possible. So Quick Charge 3.0 doesn't charge, I don't think, a hell of a lot faster than Quick Charge 2.0, but what it does is it tries to take that voltage or that power conversion out of the phone, and it does it inside the actual charging brick itself. So the charging brick will put out a voltage anywhere from 3.6 up to 20 volts, so it has a lot larger voltage range. This allows it to charge other devices off USB, which wouldn't normally be able to be powered off USB. Things like smaller laptop / tablet things, or, you know, like really large tablets, or convertible laptop tablet, you know, devices. Those things can be charged off of higher voltages, which wouldn't normally be able to be powered off of a USB port. They can now be charged on this, and so it has a very wide range, and it goes anywhere from 3.6 volts to 20 volts in 200 millivolt increments, and it is backwards compatible with Quick Charge 2.0 and 1.0. So it sounds really good, and so now your voltage conversion is actually all done in the USB charger itself, not in the phone, so you don't have any heat really. It's actually theoretically more efficient than Quick Charge 1.0 because you still have to do some power conversion in the phone on this. Again, your phone does not run on 5 volts. Your battery doesn't charge on 5 volts. It has to step that down to your actual battery voltage. So what's nice about this is you can feed the actual voltage that your phone needs directly into the phone without doing any power, theoretically, without doing any power conversion in the phone. And then that'll save it so that your phone is not doing, it's really not generating any heat due to the charging process, besides maybe a little bit of resistive losses, but there's no power conversion heat generator or anything like that. And it goes anywhere from 3.6 to 20 volts in 200 millivolt increments. I couldn't find a max current anywhere on this. I would assume it's probably the same 3 amps as this, so I couldn't really find a max current for that. But this suffers some of the same problems as Quick Charge 1.0. You can go up to higher voltages, so all the power conversion is done in the brick itself, which means it's more efficient. Not really more efficient, but in terms of heat losses and efficiency losses in the phone and in the device itself, it's more efficient. Quick Charge 3.0, however, is operating, as you can see, at lower voltages, potentially lower voltages than Quick Charge 1.0, which means you're going to need some really thick cables to transmit a decent amount of current. If you want to push a good amount of current through that cable at these lower voltages, you're going to need to have a decent sized cable, and if you use some off-brand little thin wire gauge USB cable, you're not going to be able to push a lot of current at these lower voltages. And if you want to step up to higher voltages, you can. The Quick Charge 3.0 could charge your phone, like, let's say at the normal Quick Charge 2.0 levels, which is at like 9 volts or 12 volts, but then you're going back to the same problems back here, where you're going to be doing power conversion in the phone. So there's two main problems. If you go too low a voltage, then you're going to have a lot of losses in your wire or your conductors, your USB cable. If you go too high a voltage, then you are going to be doing a lot of power conversion in your device, and that will cause a lot of heat to build up in your device. So Quick Charge 3.0 tries to kind of like balance that and keep it in the most efficient level and charge it as fast as possible, like Quick Charge 2.0. So that's pretty much what Quick Charge 3.0 does. So let's actually look at Quick Charge 2.0 in action. So before we look at that, I just want to show you a few bricks. So this is like your typical Apple iPhone brick. I don't know if you guys can see that, but right there it says 1 amp. It's kind of hard to read on this guy, but it's a 5 volt 1 amp brick. So what I've noticed, iPhones are really efficient. They're really efficient with how they use their power. Their batteries aren't really that large either, so they don't need to charge with ridiculous charge rates. Their operating system's efficient. They're overall a very efficient phone. And so they can get away with charging with something like this, although it might still take significantly longer to charge than, say, a Quick Charge 2.0 device or a 3.0 device, but iPhones are typically, they can get away with using a smaller charger like this because the phones are so damn efficient. So here's a charging brick from my Nexus 7. As you can see, it actually uses 5.2 volts. This isn't too uncommon. Again, the Samsung chargers, I've seen some with like 5.3 volts on their newer chargers, and it goes up to 1.5 amps. So that extra 0.2 or 0.3 volts kind of helps those losses, like I said, in those cables. It helps mitigate those losses so that by the time the voltage gets to your device, it will be at hopefully like 5 volts, and you'll get maybe a 0.2 volt loss in your cable, assuming you're using the OEM cable. If you're using a smaller gauge cable, then you're going to have even more losses. So that's why you'll typically see a little bit higher voltage than 5 volts sometimes. So here's this Easy and Fire. I don't know, I just bought it on eBay, but it's a Quick Charge 3.0 or 2.0 adapter, I should say. So it outputs 5 volts at 2 amps, 9 volts at, there's that 1.67 amps. I don't know why, but that's what a lot of adapters I've seen put out, and that's why I've seen a lot of devices actually take. I've put them on some pretty calibrated current measuring devices, and they actually pull like exactly 1.67 amps. So I don't know where that number comes from or what that's all about. It's actually pretty close to 1 2/3 of an amp if you actually round it off. So it's 1.66666 repeating, which is actually 1 2/3 of an amp. So I think that's where that number comes from, but I still don't know why that number. Actually, if you think about it, it actually turns out to be 15 watts exactly, so that's probably why they use that, because that would be a 15 watt charge rate. 9 volts at 1 2/3 of an amp is 15 watts charge rate. Then you have your 12 volts at 1.25 amps. So as your currents, or as your voltages get larger, it does put out less current. This particular charger does, but it will still charge faster, and you will have less losses over that cable. So this is just a typical Quick Charge 2.0 adapter. So this has the ability to do 5 volts, 9 volts, and 12 volts. So this here came with my Asus T100 Qi little laptop tablet thing. That's why I said these are good for not just like phones or mobile devices like that, but they can also be good for tablets and like laptops, 2-in-1 convertibles and stuff like that. My laptop actually charges off of a USB port, which is really cool. I like that. It has that 5 volts, 2 amps, or 9 volts, 2 amps. So this will do 9 volts at 2 amps or 5 volts at 2 amps. So it's still backwards compatible, but this does not have that 12 volt charging level because that device in particular does not utilize 12 volts. This is kind of a device specific adapter, but it is using that Quick Charge 2.0 technology, and I can charge my phone off this. But even though it says it can put out 2 amps max on that Quick Charge 2.0 or that 9-volt level, my phone will not take it. It still only takes that 1.67 amps. So my phone must have a maximum current set somewhere in the software or possibly even in the hardware. It won't take more than 1.67 amps. So let's actually hook this stuff up and let's take a look at how it operates. Alright, so I'm about to plug this thing into my phone. I have just this little cheap USB current monitor adapter thing that I bought on eBay. And so we have it plugged into that Quick Charge 2.0 charging unit, which has the ability to do that 5 volts, 9 volts, and 12 volt level. Again, my phone only utilizes the 9 volt quick charge level. But if we look at it, so right now, of course, there's no current flowing, and it's at 4.95 volts. So I'm about to connect it, and as you can see, when I initially connect it, I want to show you the screen of my phone and the voltage here, if we can get them both in the same shot. My phone will say it is charging, and then it'll give it a second. You'll see the voltage go up to 9 volts, and you will see the screen on my phone actually say fast charging. So if we plug it in, let's go ahead and check that out. So actually, in this case, it instantaneously, just damn near instantly, switched to 9 volts. Sometimes it'll take a minute, but you can see, as you can see on my screen, it says fast charging, and we're at 8.95 volts, and the current is at 0.8 amps. And for some reason, this actually has been like a mystery to me for a really long time. If someone can explain this to me, I would really appreciate it, but I have not found anywhere where this is explained. Why does my phone charge slower? Why does the current, watch the current, and it's actually not it's not charging at 1.67 amps right now, probably because it doesn't need it, because the battery is not that dead. I don't know, it's at like 66%, so it probably should charge at 1.67 amps. I don't know, it kind of like varies the current sometimes. It doesn't always charge at max current, which annoys me. But why does the current go up when my screen turns off? If someone can answer that with a legit answer that makes sense, I would like to know it. It's software, it's got to be something in software. But look, my current right now is 1.26 amps. If I turn on the screen to my phone, it instantly drops to like almost half that, like 0.73 amps, 0.84. It'll never go above an amp. And then once I turn the screen off, whoops, it goes back up. Why does my phone charge slower when the screen's on? And it's not just this phone. I've noticed it on a lot of other phones. So if someone could answer that, I'd really appreciate it, because I do not understand that, and I have not understood that for a while. And I've tried to look it up on like a bunch of sources, and I can't find anywhere where it explains why the phones do that. I don't know why. It's a good question. So that's been a mystery to me for a while. So if someone could explain that. But I just wanted to show you guys how this Quick Charge 2.0 works. So it literally uses the data pins to modify the voltage bus. So here we could see we're at 9.07 volts now, and yeah, it's just changing the voltage. And I have a short wire here to mitigate those voltage losses, those drops. But and these are thicker gauge wires. So if you use, I'll show you guys this actually on a really chinky cable. Let's look at it on a chinky cable, and I'll show you guys that it does make a difference. So I've changed the power brick. We're using that Nexus 7 charger, which puts out 5.2 volts, and it has that 1.5 amps charge rate or whatever it was. I forget what it was. But anyways, maybe it was, what the hell was it? I couldn't see it on camera. Actually, it's 1.35 amps, not 1.5, so it puts out 1.35 amps. Anyways, I'm using it with the larger, thicker gauge wires here, and if I turn the screen off, it'll step up to a higher current. So we're charging at 1.1 amps. So just to show you that this thing does charge at a decent charge rate. Now if I use this little thin cable here, I bought this on eBay, and I don't know what gauge wire this is, but it must be like close to like 28 or something ridiculous like that. It's like really thin, like it's ridiculously thin. And it'll have a lot higher voltage loss, and this phone will not be able to charge at this high a current. So right now we're charging at almost an amp. Alright, so here if we just plug this cheaper cable in, I'll go ahead and actually plug the cable in, and we'll watch the charge current. So, and I'll turn the screen off to be fair, because it charges faster with the screen off. And it's pulling a whopping 0.38 amps. So you can see that, and we are at 5.09 volts here at the actual brick or before the cable, so after the cable there's probably a large voltage loss. So my phone, this phone in particular, the LG V10, I notice is very, very, very picky with voltage drops. It will not draw hardly any current if the voltage is below, a little bit below 5 volts. So it doesn't like voltage drops at all. Some phones I've noticed, like my girlfriend's Samsung S5, her Galaxy S5, is a little bit more tolerant of these cheaper cables, and it handles those voltage drops a little bit better, but this LG V10 will draw almost no current. As you can see, it's like 220 milliamps through a thin gauge cable like this. So I actually had to go and buy a bunch of thicker gauge cables, which actually charge reasonably fast, and they utilize the maximum charge rate of most of the charging bricks I use them with. But these cheaper cables, now we're doing 0.43 amps, but we just won't see much more than that. I'd be lucky if I got a half an amp out of this cable. So let's look at it though now on the Quick Charge 2.0 at the 9 volts. It'll actually be able to charge at pretty much the full Quick Charge 2.0 charge rate, and it will be able to push that over an amp through this cable because of those higher charge voltages. Alright, so I've switched it out, so now we have the Quick Charge 2.0 adapter in, and I'm going to plug it in. So here we go. And I'll turn the screen off, that way it starts charging a little bit faster. And as you can see, we are able to push 1.4 amps, 1.35 or whatever, just as much as we were able to push before with a thicker gauge cable. We can push that same amount of current through this really cheap cable. I mean, this is honestly one of the cheapest cables I've ever seen, and it's got a really thin wire gauge, but it's able to push those higher currents. I don't think it has a really good connection either because it keeps like breaking, but we're able to push those higher currents, there it goes, through this thin gauge wire due to these higher voltages. So that is one of the benefits of Quick Charge 2.0, is that even with thin off-brand cables that you just might buy off eBay, you can still charge at a reasonably high charge rate due to those higher voltages. But again, just remember that I don't really have a thermal imaging camera, but I really would like to get one. A lot of heat is going to build up in this device because this device is going to be taking these higher voltages and converting them down to those lower voltages, and there's going to be a lot of power conversion going on in the device itself. But that is one of the benefits of Quick Charge 2.0, and I actually really like it because no matter what kind of a USB cable I have, I can charge at a reasonably fast rate. Even if it has really thin gauge wire, like 30 gauge wire, we could probably charge at still an amp at least with a charger like this at these voltages. So guys, that pretty much wraps it up for this one. I just kind of want to make a quick video just talking about Quick Charge, these Quick Charge technologies, different levels of Quick Charge, and kind of the benefits of them, because I haven't really seen another video that discusses them in great detail. You can go online and kind of read about them, and a lot of sources will just say, oh, it charges 35% faster, or it charges. No one really says how it does it, or the benefits or cons to each of them, because there are, as you saw, benefits to Quick Charge 2.0, Quick Charge 3.0, but there's also drawbacks in different ways. So I thought I'd just discuss that. That way you guys can look at those factors when you make a purchase decision, and also just be aware that Quick Charge 4.0 is going to be hitting the market soon. And I will make a video about that if I remember, and if it's significantly enough different, which I think it will be, because it's going to actually be USB-C compliant, which is a huge major step forward, because like I said, that's a huge problem with Quick Charge 2.0 and 3.0 right now, is that they are not USB-C compliant in any way, and they're proprietary, and there's major issues between USB-C and Quick Charge 2.0 mixing, or Quick Charge in general, mixing those two standards together, because one of them is actually a USB standard and one of them is just a proprietary standard used for Qualcomm devices. But that's pretty much it for this one. I hope you guys enjoyed it, and like always, have a good one.